Ever look at an algebra problem and just think, oh, where do I even start? Well, what if I told you it all boils down to one super simple idea? Today, we're going to make it all click. Let's jump in.
I want you to really think about this question. Seriously. Because if you can picture an old school scale, the kind with two pans, if you can picture that in your head, perfectly balanced, you're already halfway to solving these equations.
And that brings us right to our big idea, the balanced equation. An equation is really just a promise. It's a statement saying that whatever is on one side is exactly equal to whatever is on the other. No more, no less.
So check out our first puzzle here. On the left side of our scale, we've got x minus 5. On the right side, we just have the number 4. Our entire mission is to figure out the mystery value of x that keeps this thing perfectly level.
To solve this thing, we've got one main goal. We need to get x all by itself on one side of that scale. We want to isolate it. But, and this is the most important rule in the whole game, whatever we do, we have to keep the scale balanced. So how do we actually do that? Well, we need a tool. Let's grab the first tool from our algebra toolkit, addition. Think of this as the key that's perfectly cut to unlock any puzzle that involves subtraction. Okay, I know this looks all formal and mathy, but don't let the letters scare you. All this is saying is that if you have two things that are equal, a balanced scale, you can add the exact same thing to both sides and it will still be equal. The balance isn't broken.
So here's the simple takeaway. When you see subtraction in your problem, your go-to move to undo it is addition. You just have to remember that golden rule, you've got to do it to both sides to keep things fair.
Let's actually do it with our puzzle. X minus 5 equals 4. We need to get rid of that minus 5 to get x alone. So we do the opposite. We add 5. But to keep the balance, we have to add 5 to the other side too. Now, on the left, the minus 5 and plus 5, they just cancel each other out. Poof! All that's left is x. On the right, 4 plus 5 is 9. And just like that, we have our answer. X equals 9. But are we positive? The best thing about algebra is you can always check if you're right. Let's go back to our original equation and swap out the x for our answer, 9. So, the question is, does 9 minus 5 equal 4?
Yes, it absolutely does. 4 equals 4. That is a true statement, which means our answer was correct. The scale is balanced. We did it.
All right, you're getting the hang of this. Let's pull out our second tool from the toolkit, subtraction. And you can probably guess when we're going to need this one, right? Yep, anytime we see addition in a problem. And just like before, here's the official rule. It's pretty much the mirror image of the last one. It just says that if you start with a balanced scale, you can subtract the exact same amount from both sides, and it's going to stay perfectly balanced. So to put it simply, you see addition, you use subtraction. They're opposites. They undo each other. It's the right tool for the job. You just can't forget to use it on both sides. Let's try it out on a new puzzle. N plus 7 equals 9. To get n by itself, we have to deal with that plus 7. So we do the opposite. We subtract 7 from both sides. On the left, the 7's cancel out, leaving just n. On the right, 9 minus 7 leaves us with 2. And there's our solution. N equals 2.
But you know the drill by now. We always double check. Let's plug our answer, 2, back into that original equation. Does 2 plus 7 actually equal 9?
For sure. 9 equals 9. The balance holds. Our answer is solid. You see the pattern here? It's a reliable system that just works every single time. Now that you've seen both of our main tools in action, let's just lay it all out as a simple, repeatable method you can use every time. Here's the whole game plan. Step 1. Use the opposite or inverse operation to get that variable alone. If you see addition, you subtract. If you see subtraction, you add. Just do it to both sides. Step 2. Take the answer you got, pop it back into the original equation, and make sure it works. That's it. That's the whole process. So why have we been talking so much about this whole balance thing? Well, because it's not just a cute analogy for these simple problems. It is the absolute fundamental foundation of almost all of algebra.
This quote really just says it all, doesn't it? The core idea, the guiding principle, is that you have to keep things equal. You have to be fair to both sides of the equation.
And here's the really cool part. This one idea, this concept of balance, is the master key that unlocks everything else.
As you get into more complex algebra with multiplication, division, all kinds of crazy stuff, you'll find yourself coming back to this exact same rule over and over again. You just learned the most important rule of the game.
So, I'll leave you with this final thought. You now get it. You understand the principle of balance. You have the first two keys to unlock these puzzles. So, what other problems do you think you can solve now?